Hey everyone, I am Miss Hu, your physics teacher. In this video, we'll be learning about light reflection, where we will cover the law of reflection, the characteristics of an image formed in a plane mirror, and how to draw the image formed in a plane mirror, meaning we'll be drawing the ray diagram. Now, in this video, we're only going to be covering plane mirrors. If you'd like to learn about the curved or spherical mirrors, such as concave and convex mirrors, I'll be putting that in a separate video. So here's a little meme because my slides are not complete when we don't have a meme. Ha ha ha. Anyway, let's move on to the law of reflection. Now, before we go into the law of reflection, first of all, we must understand what's happening with the light ray. So we have a diagram here which shows clearly how the light rays behave when they hit the mirror. So this is a plane mirror. A plane mirror basically is a mirror that is flat. We have the light ray that is shown to the surface of the mirror, and the light ray will reflect off the surface of the mirror. The light ray, which is shown towards the mirror, is known as the incident ray. Sometimes we say that the light ray is incidented towards the mirror. So the term incident ray here refers to the light ray that comes from the source. The light ray that is reflected off the surface of the mirror is known as the reflected ray. Now let's see how the law of reflection applies in this situation. Now, the law of reflection is made up of two parts. And every time I say that, Canva always gives us balloons, so let's just go with it. But for most people, when they state the law of reflection, they always refer to only the first rule. Let's just go through both. Now the first part, and this is actually the most important part, is the one that defines the law of reflection. The angle of incidence is equal to the angle of reflection. So every time a light ray reflects off the mirror, it reflects in such a way that the angles on both sides are equal. So in this diagram, you can see that they've labeled this angle here as I and this angle here as R. I is the angle of incidence, while R is the angle of reflection. The angle of incidence is sometimes known as the incident angle, and angle of reflection is sometimes known as the reflected angle. Now I'm going to write this down so that it's easier for you to remember. So I is the angle of incidence, or sometimes known as the incident angle. Let me just shift this to a position that you can see. While R is the angle of reflection, sometimes known as the reflected angle. Now, one thing you must remember is that whenever we measure the angles when it comes to light rays, we measure the angles from the normal line. So you can see this is why in this diagram, we label the angles from the normal on the inside between the ray and the normal line. We do not measure the angles from the mirror surface to the light ray. Now, some students would argue, isn't it the same if we measure I equal to R on this side? That means the angle here between the incident ray and the mirror would also be equal between the ray and the mirror. Yes, you are correct. Obviously, the angles would be equal. But the reason why we measure the angles from the normal line is because later when you learn about refraction, you'll find that there'll be a calculation involved where we are required to use the angle between the normal line and the light ray. So to make it easier for us to remember, to make it homogeneous, the entire concept of light phenomena, we always measure the angles between the light ray and the normal line. Now let's get to the second part of the law. The incident ray, reflected ray, and normal line are all on the same plane, as you can see. The term plane here means the 2D surface. So you can see in this diagram here, the incident ray, normal line, and reflected ray are all on the same plane, which is how we will measure the angle of incidence and angle of reflection. You cannot have the incident ray coming in one direction, reflected ray going somewhere else, and normal line at some other plane. No. So the second part of the law is just to set the foundation in which we can measure the first part correctly, meaning how we can measure the angles correctly. Now, this diagram is in 3D, so let's take a look at how the labels should be for a 2D diagram. This is the plane mirror. The incident ray is the ray that comes from the source, and as it reaches the plane mirror, it gets reflected off. This is the reflected ray. We always have to draw an arrow on the ray to indicate that these are light rays. Without the arrow, they just look like random lines. It's also important to have the arrows because we need to show the direction in which the light rays are traveling, where they're coming from and where they're heading to. The dotted line here is the normal line. The normal line is a line that's perpendicular to the surface of the plane mirror at the point where the ray reaches the mirror. The angle is measured between the normal line and the light ray. So as you can see, I've labeled here, this is angle of I, which is the angle of incidence or incident angle, while this is the angle of R, which is the angle of reflection or the reflected angle. Now, let's get to the image characteristics. So what we're looking at here is the plane mirror. So the black line is the surface of the mirror and the gray area is the back of the mirror. So I want you to imagine every day when you wake up and you're like, okay, I'm about to go to school. Obviously, before you get out of the house, you have to make sure you look good. And how do we do that? You gotta look at yourself in the mirror. If you're not checking yourself in the mirror before you leave the house, for all you know, you've got a booger stuck to your nose and you don't even realize it. That's why mirrors are so important in our daily lives. So, say this is you and you're checking yourself out. Ooh, I look so hot! Superstar. Right, superstar, here you go. So when you look at yourself in the mirror, what do you see? You see a copy of yourself in the mirror. It's like there's a clone of you that you're looking at that's doing everything that you do. So when you raise your hand, your clone also raises their hand. When you shake your foot, it also shakes its foot. The only difference is that it is on opposite sides. When you lift your right hand, they lift their left hand. So just to help us visualize, I'm going to draw that copy that we see of ourselves in a mirror. Now, my drawing is not great, so bear with me. Just look at this giant head and think of how amazing you look. All right, so this is the real thing. You are the OG, and we're looking at this Faco who is basically copying your every move. So the real thing is known as the object. I'm going to label here, this is the object. What we see in a mirror is known as the image. In everyday language, we call that the reflection. But in physics, we say it's an image because it is something that is formed due to a light phenomenon known as light reflection. So to differentiate between the real thing and the copy, the real thing is known as the object and the copy is the image. So when we need to state the image characteristics, basically we need to compare the image against the object and find out what's the same and what's different. So here are the image characteristics of the image formed due to light reflection on a plane mirror. Just going to write the term plane mirror here to make this really clear that this applies only for the plane mirror. First of all, the image distance is the same as the object distance. What does this mean? The object distance refers to how far away the object is from the surface of the mirror. This should be quite logical, right? So when we see ourselves in the mirror, how far away we stand from the mirror is equal to how far away our image appears to be from the mirror as well. Like when you're far away, the image is far away. When you come closer, it comes closer. So measuring from the surface of the mirror, you'll find that the image is also the same distance. Just to point out one thing, the image appears to be formed behind the mirror. Some students have told me they thought the image is formed on the surface of the mirror. That's not what we mean. When you look at the mirror, it's as if there's something behind the mirror. So when you stand further away, you come closer, it comes closer. So when you look at it, it is as if there's something else behind the mirror. That's why we say the image is formed behind the mirror and the image distance is the same as object distance. Now in terms of size, the size of the image is exactly equal to the object size. That's why we say it's the same size. Laterally inverted here means horizontally inverted. The right becomes left and left becomes right. However, the image is upright. Upright means the right way up, because if you're standing with your head up and you're looking at your image, the image also has their head up. So they're not upside down. The term upside down is opposite to upright. The image is also a virtual image. It cannot be projected on a screen. What we mean by projected on a screen is like, if you can remember those film projectors where there's light shining, it shines the film onto the screen. That's what we mean when we say the image can be projected on a screen. Those kind of images are known as real images. However, when it comes to a plane mirror, this is a virtual image because we know the image is formed behind the mirror. And if you think about it, okay, can we get this projected on a screen? You know the image is formed behind a mirror. Try to place a screen or a piece of paper or something to capture that projected image. Place it behind a mirror and see if you can get an image to be formed on screen. That statement doesn't even make sense, right? You're like, obviously, duh, nothing's going to appear on the screen. So a virtual image is an image that you can see, but you can't make it appear projected onto another screen. If this doesn't quite make sense, please watch my video on thin lenses where we will cover in more detail the difference between real and virtual images. For this video, we're going to focus on reflection. Now, we're going to learn how to draw an image formed by a plane mirror due to light reflection. So for this, I'm going to switch my app to a whiteboard app where I can draw more accurately. Alright, so I've switched to this whiteboard app because drawing in this app is so much easier, especially when it comes to drawing the lines compared to the other app. Now I'm going to do now is going to show you step by step on how to complete the ray diagram in order to obtain the image formed from the plane mirror of the object due to light reflection. Whew, quite a mouthful. Basically, we're going to learn to draw the image. Now you're probably like, well, it's quite obvious the image is behind the mirror. That's what we've just learned in the previous slide, correct? But when it comes to your exams, you are required to draw the ray diagram using a whole bunch of light rays to show where the image is formed. So this ray diagram actually shows us clearly how come we observe the image to be formed behind the mirror. So this is the object. In fact, I'm going to label the object. This is the object. Now, in order to obtain the image, we need to draw the light rays, and the light rays need to obey the law of reflection. So now, let's learn to draw the image. Now, I've got the procedure written here, and hopefully this procedure will help you in completing the ray diagram for light reflection. So the first thing we're going to do is going to draw the light rays. In fact, I'm going to draw it as an arrow because normally when we want to draw the light rays, we always have an arrow because an arrow indicates that it's a light ray. Otherwise, if you just draw a straight line, it's like, what is this line? So one of the indications to show clearly this is a light ray is by drawing the arrow. And the arrow is also important to show the direction in which the light ray is traveling. Because it's traveling from the object to the mirror, this is the incident ray. So we're going to draw two of this. We're going to have both of them start from the same point, but they're going to go to different positions on the mirror. Now, based on the law of reflection, the incident angle is equal to the reflected angle. So regardless of whatever angle that the light ray reaches the mirror, it will reflect back with their own respective angles, which are equal to the respective incident angles. So I'm going to draw the normal line here. I'm just going to shift it so that it is aligned with the position here. And I've put a normal line here as dotted lines just to make it clear that these are not light rays. These are actually normal lines. I'm just going to label it as well. So we've drawn the light rays towards this point because this is the what I call a floating eyeball. That means that's the eye of the beholder. The light rays need to be reflected towards the eyeball. Because if the eyeball was on the other side, then you have to draw the light rays towards where the eyeball is. Now the next part is you should use a protractor. Because I'm drawing this virtually, I don't actually have a protractor, but if you're drawing this with pencil and paper, you do need to use a protractor and measure the angles accurately. Now because I'm drawing this virtually, I don't actually have a protractor. So let's just imagine I've used a protractor and let's estimate this by sight. I'm going to change this to a solid line. And let's make the angles equal on both sides. And we're going to also do this for the second light ray. So we have the two incident rays and the two reflected rays. Now, to understand how to obtain the image, you have to understand the image is formed due to the reflection. That means the reflected rays will need to form the image. The reason why we start the incident rays from the same point on the object is because if we can find the two reflected rays intersecting at the same point, that will be the position of the image. So by starting on the same point on the object, incident ray, so when we have the reflected light rays, where they intersect, that's where the image will be formed. The thing is though, if you look at the two reflected light rays here, you can see that they're both diverging. They're not going to intersect. Even if we extend the light rays here, there will be no intersection on this side. Oh, so how? Where are we going to get an intersection? As it says here, if there is no intersection point on the reflected light rays, extend the lines back. So because there's no intersection here, we need to extend the light rays backwards. So let's get the line. Okay, we're going to make sure the line is an actual extension. They have to be straight. Now the extended lines should be dotted. Why? Because the light rays don't actually travel here. See, we draw these lines as solid because these are the actual paths of the light rays. But if we're extending the lines backwards, these are guidelines. The light ray does not actually travel along this path. So because these extension lines are for human beings to see, these are our guidelines or extension lines, we draw them as dotted lines. So we're going to do this as well for the second light ray. I'm just going to fix this to make sure that they are in a straight line. And as you can see, yes, it's the intersection point and it is at equal distance from the surface of the mirror as the object. So this position is where the image is formed. So the reason why we see the image formed behind the mirror is because that's how the reflected rays intersect. When we look at the mirror from this position, we perceive the image to be formed at this point. That's why the image is from behind the mirror at an equal distance from the surface as the object. Just a note, if the image is formed in at least one dotted line, the image is virtual. To understand this a little bit more, I have covered this in my video about thin lenses. For now, we already know that the image formed by a plane mirror is virtual. So now that you understand how to draw the image, I'll show you a faster way to obtain the image. Let's look at the same diagram again. This time, instead of drawing the light rays at two random angles, we'll still need to draw two light rays, but this time we're going to draw one that is perpendicular to the surface of the mirror. Why? Because if it's perpendicular to the surface of the mirror, the incident angle is 0, therefore the reflected angle is 0, which means that it will reflect back at exactly along the same path backwards. So this will make it a lot easier for us to obtain the image. The second light ray does have to be at an angle, but now it's much easier for us to obtain the image. Let's complete the diagram. I'm going to put the normal line here. Normal line, I'm going to put it as dotted. Okay. And we're going to draw the reflected light ray here. So I'm just going to adjust this to make sure that the angle is equal on both sides. Now we know we need to extend the light ray backwards. The reflected light ray should be here. Let me just draw another one here. So you can see it has traveled to the mirror and reflected backwards, just to make it a bit complete, you know. And let's extend this backwards. Let's make this dotted. And also this line. And as you can see, this is a much easier way to obtain the image form. This can be accepted because as long as you have two light rays that clearly obey the law of reflection and you get the intersection point of the two reflected light rays, it is correct. Just going to complete the labeling here. This is the object and this is the, is the image. So I've just shown you how to draw the ray diagram virtually. Next, I'm going to show you how to draw the ray diagram on an actual piece of paper. Now I'm going to show you how to draw a ray diagram on a piece of paper using a pencil, a protractor, and a ruler. What we have on this paper here is a diagram of the plane mirror, an object, and the eye of the beholder who is going to be observing the image of the object formed by the plane mirror. We're going to start off first by drawing two light rays from the same point on the object. So the point has already been marked for us. We're going to draw two light rays at random angles. The angles don't matter because as long as we measure the angles correctly for each respective light ray, we can still get the answer. So here are the two light rays. And next, what we're going to do is we're going to have to measure the angle of incidence for each respective light ray. Let's start with the first one. So we line up the protractor with the point of the light ray where it touches the plane mirror. And this is the normal line. So I'm marking it here. Now remember that the angle of incidence is always measured from the normal line. So we can see that the angle is between 90 and 68, which means that the angle is 22 degrees. So we're going to mark the same value over here, which means we need to mark 22 over here. Now to make this easier for us, we know that the number on this side is 68. So we're going to mark the same number, 68 on this side as well. So 68 is about here. To make this diagram complete, I'm going to draw the normal line out. So this is the normal line. I'm going to mark this as N. And we're going to connect this point where the incident ray touches the mirror to this point we have marked. This would be the reflected ray. We're going to do the same thing now for the second light ray. So again, we're going to align our protractor with the point where this incident ray touches the plane mirror. This is the normal line. We're going to mark it here. And as you can see, the angle between the normal line with the incident ray is between 90 to 50 degrees, which means that it is exactly 40 degrees. Now, it so happens to be a lovely round number. Sometimes it's not planned, but if it works out, it works out. So 40 degrees, which means that we would need to mark here 40 degrees. So that's at 50 because 0 to 50, so 0 to 50 on this side as well. So this is the normal line. And we connect this point to this point, which we had marked from the protractor. This is the reflected ray. Now the light rays don't quite reach the eye, but it's fine because the eye is just roughly where the light rays should be headed towards when they reflect off the plane mirror. Now, in order to obtain the image of the reflection, we must find the intersection point of the reflected light rays. But as you can see from this diagram, the two reflected light rays are diverging. Even if we keep extending them, they will never intersect because they're getting further and further away. So, how do we get the intersection then? We need to extend them on this side. That means we need to go behind the plane mirror. So in order to do that, we need to use our ruler and extend the line backwards. So we're going to align our ruler with the first reflected light ray. And every time we extend a light ray backwards, we have to draw dotted lines. The reason for this is because solid lines are always used to represent the actual ray paths. So the light ray actually travels along these paths. But light rays cannot travel behind the plane mirror. These lines are extension lines or guide lines. Because the light rays don't actually travel this way, that's why we draw them as dotted lines. So we're going to do the same thing for the second light ray. And now we can see there is an intersection point here. This is the point where the image is formed. Of course, this is the object. Now, if we had drawn this all correctly, what we'll find is that the object and image would be lined up in the same line and they will be equal distance from the surface of the mirror. Let me just shift it here so that it's a little bit clearer without the glare. What if the exam question has given you the two light rays, but if you're having trouble getting the image to be in the same line as the object and equal distance? Well, let me show you. So we're going to start again from here. I don't have the two light rays, so again I'm just going to draw two random light rays from the same point towards the surface of the plane mirror. Now, we know that for an image that's formed in a plane mirror, it has to be equal distance from the surface of the mirror as the object is from the surface of the mirror, and yes, they have to be in the same line. So here's a tip on how to draw in such a way that you can get the correct answer with very minimal fuss. It's not really cheating because we're making use of our knowledge. Yeah, but it's a quick way to make sure we can get the correct answer. What you do is you place your mirror in such a way that you align the object to the mirror, measure the distance out. You can see it's 6 centimeters. And we're going to mark a point here, exactly 6 centimeters as well behind the mirror. We know, based on our knowledge of reflection, that this has to be the position where the image is formed. So we already have the image position. Actually, what you can do is from this point, straight away, draw the light ray out. So from here to this point, we'll draw dotted to the plane mirror, and on this side, solid, because this is the actual ray path of the reflected light ray. Then we're going to do the same thing here to here. And there you go. So I didn't even use my protractor for this. If you want to verify, are the angles equal? You can just do a quick check. And you can see that yes, the angle is exactly the same from the normal line here, 90 to 75. So that's 25 degrees. 90 to 75, also 25 degrees. If we check the second light ray, again, let's just align it to double check. We have from 90 to 48, so that's 42 degrees, and also 90 to 48, also 42 degrees, so the angle is equal for both sides. So in this case, it's not really the correct method because we're not using the protractor to get the reflected light rays, but this is a quick tip to help you quickly obtain the image, because I know sometimes in the exams you don't want to spend so much time drawing, erasing and redrawing just to try to get the correct image position. Use your knowledge of the law of reflection to straight away get the image position, and then use that to help you draw out the light rays. So now let me give you a tip, a much easier way to get the image formed by the reflection, and you're always going to get it at a perfect position every time. Usually the question paper would give you the two light rays, but if you were given a situation where you had to draw the light rays yourself, I suggest that you draw the first light ray perpendicular to the surface of the mirror. Now, why do we want to do that? Because if the light ray is perpendicular to the surface of the mirror, that means the incident angle is 0. Therefore, the reflected angle will also be 0, which means that the light ray will reflect at exactly along its own path. Then you just need to draw one more light ray to the surface. Angle can be random. And you only need to measure out the angle for this light ray. You don't have to draw it for two light rays because the first one was already perpendicular to the surface of the mirror. So what we have here is an angle of about 48 degrees from the surface of the mirror, which means it's about 42 from the normal line. So we're going to do the same thing, about 48 over here. It's the normal line. And this is the reflected light ray. So in order to obtain the intersection of the reflected light rays, we just need to extend this light ray as well as this light ray. And you can already see how easy it is to obtain the image position. So this is the image position, of course, is the object. Let me write that in full. And you can see how easily it lines up with already the perfect position and equal distances. So is this method accepted? Yes, because you need to draw two light rays, and this light ray still counts because any light ray that reaches the mirror at a right angle, meaning incident angle equals to 0, will always reflect back along the same path. So this still counts because this still shows us the correct behavior of a light ray that reflects off the plane mirror. So these are the different methods on how to draw the ray diagram to obtain the image formed by the object in a plane mirror. And that's it for this video. I've only covered plane mirrors in this video. If you'd like to know more about curved mirrors or spherical mirrors, that means concave and convex mirrors, I will put that in a separate video. So if you found this video to be educational and helpful, please click like, do subscribe for more free physics lessons, and check out my YouTube channel for videos on other topics which you might find helpful. If you'd like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page. That's ko-fi.com/physicsrocks. For notes, quizzes, and syllabus updates, do check out my website at physicsrocks.com. Happy studying!